Analysis of simple truss, part 2, presented by Professor Khamkar UP, working as a lecturer in Civil Engineering Department, विश्वेश्वरैया अभियांत्रिकी पदविका महाविद्यालय ALMALA, Latur. In part 1, we will see what is truss, types of different trusses, component part of trusses, classification of trusses, assumptions in analysis of trusses, types of truss connection, and one simple numerical problem. In this part, we will solve the cantilever truss and simple supported truss by method of joint. Let's see first analysis of cantilever truss. This is one cantilever truss as shown in figure. There is a two forces 15 kilonewton and 20 kilonewton are acting at joint B and joint C as shown in figure. Now we calculate the forces in the different member. To calculate the forces in members, we will first calculate theta, the angle. Therefore sin theta is equal to opposite side divided by hypotenuse. So we will get the theta, the value of theta is 45 degree. Now consider joint C and draw a free body diagram at joint C. This is first force, which is horizontal FCB, and this is second member, which is inclined FCD. The inclined member we resolve first in two directions, that is horizontal and vertical direction. Horizontal force is FCD cos 45 and vertical force is FCD sin 45. At a joint C, 20 kilonewton force is applied in downward direction. To calculate forces in the member FCB and FCD, we will apply the conditions of equilibrium. That is, summation f of x is equal to 0. In the left direction, we will take negative. In right direction forces, we will take as a positive. Therefore, minus FCB minus FCD cos 45 is equal to 0. Therefore, FCB is equal to minus 0.707 FCD. We didn't know the value of FCD. So, applying second condition of equilibrium, summation f of y is equal to 0. There is two vertical forces, that is 20 kilonewton and FCD sin 45, which is applied in downward direction. So, both taken as a negative. Minus 20 minus FCD sin 45 is equal to 0. Therefore, by solving this equation, we will get FCD minus 28.28 kilonewton. The value of FCD put in above equation, and we will get the value of FCB, which is 20 kilonewton positive. Therefore, final forces in the member FCB is equal to 20 kilonewton tension and FCD 28.28 kilonewton compression. Now consider joint D and draw a free body diagram at FBD. This is the free body diagram at joint D. At joint D, three members are connected, which is DE, DB and DC. The member DC is inclined, so resolve that member in two components, that is horizontal component and vertical component. Horizontal component FCD cos 45 and vertical component FCD sin 45. By applying condition, summation f of x is equal to 0. Minus FDE minus FCD cos 45 is equal to 0. By solving this equation, we will get FDE is equal to minus 20 kilonewton. Now apply the second condition of equilibrium, that is summation f of y is equal to 0. There is vertical forces are FDB and FCD sine 45. FDB is in upward direction, so taken as positive, and FCD is in downward direction, so taken as negative. By solving the equation, we will get the value of FDB, which is now consider joint C. At joint C, the free body diagram is as shown in figure. The 20 kN force is acting at joint C. To resolve forces are FCD cos 45, FCD sin 45. By applying summation f of x is equal to 0, we will get the value of FCB. The final forces are FCB 20 kN in tension and FCD 28.28 kN in compression. Now consider joint D and draw a free body diagram at joint D. By resolving DC, summation f of x is equal to 0, applying equilibrium condition, we will get FDE minus 20 kN. Second condition, summation f of y is equal to 0, we will get the final forces in the member are now consider joint B. At joint B, FBD, FBC, FAB, three members are connected. By applying summation f of y is equal to 0, the vertical forces are 15 kN, FBD, FBE, sin 45. Three vertical forces, therefore we take the summation of these three forces, minus 15 minus FBD minus FBE sin 45 is equal to 0. By solving this equation, we will find the value of FBE, which is minus 50 kilonewton. The negative sign, therefore FBE is equal to 50 kilonewton compression. Now applying summation f of x is equal to 0, the horizontal members are also 3. FBC minus FAB minus FBE cos 45 is equal to 0. By solving this equation, we will get the value of FBE, that is 55.35 kilonewton, which is positive, so it is in tension. The final forces in the members are 20 kilonewton tension in member BC, in member ED 20 kilonewton compression, in member DC 28.28 kilonewton compression, in member DB 20 kilonewton tension, in member ED 55.35 kilonewton tension, in member BA 50 kilonewton. Now move out for second problem, that is simply supported truss. A simply supported truss is as shown in figure, in which at joint B, 100 kilonewton downward force is applied, and at joint C 80 kilonewton of force horizontally is applied. The AF, FE and ED all spans are of 3 meter, and the height of truss is also 3 meter. To analysis the simply supported truss, we will first calculate the support reactions at A and D. For this problem, horizontal and vertical both forces are acting. So at every roller support, there will be horizontal as well as vertical reactions are occurred. In this problem, it is at A. So at A, two reactions, that is RAH and RAV, is calculated, and at D, RDV is calculated. The free body diagram of forces to find the support reactions. There are two reactions at A, that is vertical reaction and horizontal reaction. The 100 kilonewton force is applied downward direction and 80 kilonewton force is applied in horizontal direction. As shown in figure, the distances of 100 kilonewton force from A is 3 meter, and of horizontal force from A is also 3 meter. Now applying condition summation f of x is equal to 0, minus 80 plus RAH is equal to 0, and RAH is equal to 80 kilonewton. The final horizontal reaction is 80 kilonewton. Now applying second condition summation f of y is equal to 0, RAV plus RDV is equal to 100. Now applying moment condition summation of MA is equal to 0 by taking moment about A by of 100 kilonewton and 80 kilonewton and RDV. The equation is 9 RDV is equal to 100 into 3 plus 80 into 3. By solving this equation, we will get the value of RDV, which is 6.67 kilonewton. The value of RDV put in equation number 2, we will get the value of RAV, which is 93.33 kilonewton. The final reactions of this truss is RAH 80 kilonewton, RAV 93.33 kilonewton and RDV 6.67 kilonewton. Now we will calculate the forces in the members. First, we consider joint A and draw a free body diagram at joint A. This is joint A. At joint A, two members are connected, that is AF and AB. At joint A, vertical reaction is 93.33 kilonewton and horizontal reaction is 80 kilonewton. The inclined member resolve in two forces, that is FAB cos 45 and FAB sin 45. By applying condition summation f of y is equal to 0, summation of vertical forces, there is two vertical forces, that is FAB sin 45 and 93.33 kilonewton. Both are in upward direction, so taken as positive. The equation is 93.33 plus FAB sin 45 is equal to 0. By solving equation, we will get the value of FAB, which is minus 131.98 kilonewton. Now applying second condition, summation f of x is equal to 0. In this, there are three horizontal forces, that is 80 kilonewton, FAF and FAB cos 45. All are in right direction. So by solving this equation, we will get the value of FAF, which is 13.32 kilonewton. So final forces in the members: FAB 131.98 kilonewton compression and FAF 13.32 kilonewton tension. Now consider joint F. At joint F, three members are connected, which are FFE, FBF and FAF. To calculate apply condition summation f of x is equal to 0. Horizontal forces are 2. So minus FAF plus FFE is equal to 0. Therefore, FFE is equal to 13.32 kilonewton. Now applying second condition, summation f of y is equal to 0. In vertical forces, there is only one force, FBF. Therefore, the value of FBF is equal to 0 kilonewton. Therefore, final force at joint FFE is equal to 13.32 kilonewton, which is in tension, and FBF is equal to 0 kilonewton. Now consider joint B. At joint B, there are four members are connected: FBC, FBE, FBF, and FAB. And by resolving inclined forces in horizontal as well as vertical direction, at a joint B, 100 kilonewton force is applied in downward direction. First, applying summation f of y is equal to 0. The vertical forces in this joint B are 4. The summation is taken as all four forces, that is FBF minus 100 plus FAB sin 45 minus FBE sin 45 is equal to 0. By solving this equation, we will get the value of FBE 9.44 kilonewton. Now applying second condition, summation f of x is equal to 0. There are horizontal forces are also 3. FBC plus FAB cos 45 plus FBE cos 45 is equal to 0. By solving this equation, we will get the value of FBC is equal to minus 86.64 kilonewton, which is negative. So final forces at joint B, FBE 9.44 kilonewton in tension, and FBC minus 86.64 kilonewton, which is in compression. Thus, consider joint D and calculate the forces in the member FDC. By applying condition summation f of y is equal to 0, we will get the force FDC is equal to minus 9.43 kilonewton. The negative sign indicates the compression in the member. Similarly, FDE 13.34 kilonewton. The final forces in the members are as shown in figure. First, 13.30 kilonewton tension in AF. In AB, 131.98 kilonewton compression. In BC, 86.64 kilonewton compression. In CD, 9.43 kilonewton compression. In BF, there is zero force. In BE, 9.44 kilonewton tension, and in FE, 13.32 kilonewton tension. In part 3, we will discuss about analysis of truss by method of section. Thank you.